Ambo. This will be a very short set of notes on nuclear reactor. We've just talked about nuclear fission. Nuclear reactor involves nuclear fission. So what you're seeing is we have to go back to our earlier chapter on electricity, making electricity. Whoa, that was a nice big arrow, with our generator. But first we want to talk about the nuclear fission. So here's our reactor. It says we have a reactor building. We've got heavy water in our system. That's used in moderator. We're going to have our uranium-235 if that's our fuel. And the bottom line is we're going to make heat. That heat is going to heat up water, and that water is going to become steam. The steam is going to run through a pipe, and it's going to spin a turbine. If it spins a turbine, now it can spin a magnet inside our coils of wire. And once we have that, then we can make alternating current that goes out onto the grid. And of course, this will just be a cycle. Keep cycling water, keep reheating it, and keep powering it. So, can-do reactor, little Canadian connection there. The next thing is a nuclear chain reaction. What we see is this is trying to give you a picture of what's going on. So here's our uranium-235, and you'll see all kinds of uranium-235s rattling around. We hit it with a neutron. When we hit it with a neutron, now it becomes even more unstable and it splits. But we don't know how it's going to split. So in this case, it became barium-141, and it also became krypton-92. And you'll see it had 3 neutrons. And you can see this neutron's going out, and it's hitting another uranium-235, and this split was into antimoney and niobium, and it also generated 3 neutrons that can go out and fission other nuclei. We look at this neutron here, hits uranium-235, and all of a sudden we're making xenon and strontium in 3 neutrons. Sometimes it'll make 3 neutrons, and you can also see occasionally makes 2. But we have all kinds of different combinations. We don't know what elements we're going to get after the split. We do know they're going to be radioactive because they're going to have too many neutrons. But this is what we call a chain reaction. 1 neutron comes in, 3 go out. Here's our 3, and then you look, oh, now we've got 6 coming out in the next round, and so on. You could add all those things up. So a successful nuclear reaction is going to be called a chain reaction, where you get more and more nuclei fissioning. So that's our brief little recap of nuclear fission in terms of a chain reaction and a nuclear reactor.